Hello and a very warm welcome to all the participants. Thank you for joining the Indian Ocean Seminar, co-hosted by the Early Career Networks of SOLAS and IOE2. We have two speakers today, Zahor and Apurva. And first, we should start with a brief introduction about the Early Career Networks of both the organizations. So I'll start Liselotte to please start her presentation on the SOLAS ECS.
Yeah, thank you, Mansi. As Mansi said, there's two organizations at the base of this seminar, and one of them is SOLAS, and they have an early career scientific committee since not a very long time, and I'll just introduce you what SOLAS does, how it can be maybe interesting for you, and what we do as an early career scientific committee. So SOLAS, for those who don't know it, it's the Surface Ocean Lower Atmosphere Studies. It's an international organization focusing on, as the name said, it, surface ocean and lower atmosphere studies. Don't seem to be able to go through the slide. Yes. And so their mission is to achieve a quantitative understanding of the key biogeochemical and physical interactions and feedbacks between the ocean and the atmosphere, and of how this coupled system affects and is affected by the climate and global change. And if you want to know more about the exact missions of SOLAS, we have a website, and you can also follow us on Twitter. SOLAS is directed by a scientific steering committee, and it has 18 members from 14 different countries, which you can all see here. Maybe you recognize some people from your region. There's, for instance, people from India, maybe you know some of them. And there is one representative from the Early Career Scientific Committee, that is Joan Lord from Spain. We also have two international project offices. One is in Galway in Ireland, which is currently empty, so we look for somebody to fill that position. And then there is an international project office in Xiamen in China, and Yan Yang, who is present today, is belonging to that project office. And so there is also a SOLAS structured research master's program, which is based in Galway in Ireland, and that is supported by SOLAS. And it's a one-year program on ocean, atmosphere, and climate. And it's a collaborative project between the University of Galway and SOLAS. And it will open again normally in September 2024. So if you're interested, you can have a look at that master as well in the University of Galway. As I mentioned already, we have an early career scientist committee, and with people from all over the world, as you can see from the map. So all the continents are represented. We're very proud of that. It was launched in January 2023, and it's a strategic and operational body to coordinate and champion early career scientific activities. And some of the activities I've listed here, but we're quite active as a committee, so we do a lot of things. We've organized a first workshop between early career scientists from SOLAS. We've organized a fire science learning across the Earth system workshop in Bermuda in the USA in 2023. We organized a side event at the WCRP Ocean Open Science Conference in Rwanda in 2023. We organized side events at the UN Ocean Decade Conference in April this year. There were also special sessions to mark the 20-year existence of SOLAS at AGU in the States in 2023, and at EGU this year in April in Vienna. And then we also help a lot to work towards the new SOLAS science plan, because SOLAS is renewing its science plan. It's a 10-year plan, and it's ending in 2025. So we need to come up with a new future perspective for SOLAS. And then we are also involved together with the local committee to organize the Early Career Scientist Day during the SOLAS Open Science Conference and other things. are going on as well. So we see there's a lot of different things we are involved in, and it's very nice to be involved in all this. SOLAS also has national and regional networks. There's 33 national and regional networks that are coordinated by 37 representatives and 1 regional panel. And you can see all the dots represent national or regional networks. They produce reports. And if you're interested, you can go to the link and read some of the reports that might be useful for you in your region or from your nation. SOLAS is organized at the moment until 2025 around these 5 core teams. The first one is greenhouse gases and the oceans, air-sea interface and fluxes of mass and energy, atmospheric deposition and ozone biogeochemistry, interconnections between aerosol clouds and marine ecosystems, and ocean biogeochemical controls on atmospheric chemistry. So a strong biogeochemical focus that might shift a little bit in the future. Well, I'll go quite quickly through these core teams. If you're interested in this, you can go in to the SOLAS website. I have some more information on each of these. But so these are all the separate core teams I've just mentioned. And then there's also some integrated, so some cross-cutting teams, such as upwelling zones, polar oceans, or the Indian Ocean, and that's where we come in with the come in touch with the IIOE. And also we try to have as a cross-cutting team the evaluation of environmental efficiency, efficacy, and impacts on climate interventions. And there's also another one on focused on science and society, which focuses on impacts of ship plume emissions on ocean biogeochemistry, on blue carbon, open ocean stewardship, and the blue economy can also go in there a little bit. SOLAS supports also or sponsors a lot of different activities, and you can see them all here. I don't know all the acronyms, there's too many, but some are sponsored projects, some are endorsed projects, and then SOLAS also endorses time series stations, which you can see in green. What are we doing next? So I've listed some of the upcoming events. We have our big Open Science Conference in Goa in India in this November. So from the 11th till the 15th of November, the registrations are still open for that. And then in January next year, we will participate in the Xiamen Symposium on Marine Environmental Sciences. And that for that conference, the call for sessions or events is open. And we also project to organize a workshop on sea surface plastic from space next year, early next year in Italy. And if you want to know more about us, you can follow us through all the different links you can see here, or contact us. And I hope to see some of you coming up next. Okay, Mansi, over to you for some IIOE information.
Yes, my screen is good. Yeah. Okay, so hello everyone. My name is Mansi Gupta, and I'm a PhD scholar at the Physical Research Laboratory in Ahmedabad, India. Thank you all for joining us today. So in the next 5 minutes, I'll be presenting an overview of the objectives and activities of our network and some of our major projects. So the IIOE2 ECSN was formed in December 2015 at the National Institute of Oceanography in Goa. The objective of the network is to firstly support the early career scientists in Indian Ocean, foster collaborations among these researchers, organize events for knowledge sharing, connect with groups sharing similar goals like SOLAS ECS, and then bridging the ECSN with senior scientists with the IIOE2 working groups. We have over 100 members from around 17 different countries. So this slide shows here the current core committee of the IIOE2 ECSN. Dr. Fahmi Dil Mahmood and Dr. Aditi Modi are our chair and co-chair. And we have other members, including Dr. Danija Moran, Dr. Sudesh V, Dr. Himanshu Saxena, Mr. Matthew Carr, Dr. Chandan Lal Farida, and Mr. Shubhadeep Chaudhary. Our core committee members are at different stages of their careers, and they come from 8 different universities and institutes across the world. Along with this, the current core committee is also accompanied by our advisory committee, who were also our former members, and they include 5 of them: Arvind Singh, Nimit Kumar, Daniel Su, Eric Riaz, and Michelle Fernandez are right now among our advisory committee members. We also, our members are also part of several early career research groups such as APSO, NANO, IMAPS, POGO, ECOPS, even Decade, EGU, PORSEC, and NOAA. And we are also creating a nested network. So what we're doing is by identifying institutional leads, which license with the ECSN core committee, and they revert back to the network at their institutes. And overall, this will be a part of they will be part of ECSN community. And through this process, basically, we aim to effectively showcase ECR contribution, foster collaborations, and amplify the impact of Indian ocean research in various institutes. So if anyone is interested in being the institutional lead for IOE to ECSN, please contact us through our email or our website. Other than that, recently, through INCOIS, our project Decade IO, which stands for Devising Early Career Capacity Development in Indian Ocean Region, it was endorsed by UN Ocean Decade. It aims to enhance the capacity building for ECRs in the Indian Ocean region through organization of trainings where ECRs are the trainers as well as mentors. So the first Decade event was actually conducted in last September in INCOIS ITCO Center. And you can check the details on our website. We also host a seminar series called Ocean Insights, where we get ECRs from different backgrounds in oceanic sciences, giving a talk on first Friday of every month. So if anyone working on Indian Ocean is interested in presenting their work or sharing their ideas with the Indian Ocean community, please contact us. And these are some of the seminars that have been held in the Ocean Insights seminar series. The recorded versions of all the seminars is on our YouTube channel, so you can visit that and check. For more information, you can visit our website using the QR code on the screen, which has information about how to join the network, the profiles of the core committee, and what we are doing as a team to enhance the communication and collaborations between ECRs. So at the end, I would like to say latest updates and events from IOE to ECSN and newsletter, brochure, and media news is also shared through social media platforms of IOE to ECSN. It's basically aimed to reach a larger audience community. And this network, IOE to ECSN, is arguably the oldest and one of the few only basin-focused multidisciplinary EC networks globally, and we are interested in building a bigger network community of early careers. So if anyone is working in the early stages of their career and is doing research in any branch of oceanic sciences, we invite you to join our network, and you can check out the QR code on the screen. Also, you can check out our website, and as well as email us for any contributions or interests you have. Thank you very much. Okay, so with this, So with this, now I'll introduce the first speaker for this event, Zahor Khalfan. I'll give a brief introduction for Zahor, and then he shall share his screen, and then we can start. So Zahor has a master's degree in marine biology, obtained in 2020 at Zhejiang Ocean University in Laoshan, China. He currently works as a researcher in Zanzibar Fishery and Marine Resources Research Institute in Zanzibar, Tanzania, since 2023, where they work on blue economy and marine conservation. During his master's, he has worked on the speciation of Polychaetus worm in different oceanic basins. Now his work focuses on the blue economy and particularly seaweed farming in the Indian Ocean and around Zanzibar. So Zahor, please share your screen, and we are excited to hear about your work.
Thank you. Okay. Firstly and foremost, I would like to deliver my sincere appreciation to organizer of this program, the early career scientist, and then SOLAS. So specifically, thanks go to Dr. Liselotte, Tinel, and Mansi for, and as well of the committee for organizing this program. My name is Zahor Khalfan. I'm currently working at Zanzibar Fisheries and Marine Resources Research Institute. So our institute specifically is doing the applied research that is basically in coastal community livelihood. Our research institute is under Ministry of the Economy and Fisheries, Zanzibar, Tanzania. So let me go direct to my presentation today, that I will talk about the seaweed evolution, status, and the recent development in Zanzibar. So before going further, I would like to briefly explain about ZAFIRI. ZAFIRI is a newly established research institute, which is found in Zanzibar, which is work under the Ministry of the Economy and Fisheries. Our mission is to conduct a state-of-the-art of research utilization of marine resources, development of fisheries and aquaculture sectors, and safeguarding marine ecosystem and marine environmental at all. So our mission is to be a world-class institute for fisheries, marine resources, and marine science research in the Western Indian region, with your countries. So I would like also to explain a little bit about Zanzibar. Zanzibar is an archipelago, is a semi-independent archipelago within the United Republic of Tanzania, and its population is about 1.8 million. Majority of coastal community livelihood in Zanzibar heavily rely on marine resources utilization. The island is in the Indian Ocean, which is about 20 to 50 kilometers off the coast of African mainland. Zanzibar consists of many islands, small islands, with major two islands, which is Zanzibar, which is Unguja and Pemba. Unguja referred as Zanzibar. Apart from tourism, seaweed farming is an important alternative livelihood activity that has been heralded as a development success story. So while we are proceeding about this presentation, let's talk about the short history of seaweed farming in Zanzibar, Tanzania. Actually, the seaweed farming started, along the coast collection of the seaweed near the coast. In 1950, it's about 4,000 exported dry seaweed was exported in Europe. So, but the collection was not yet, consistent. In 1970, there is a collapse and overexploitation of seaweed due to the many factors. When you talk about Zanzibar seaweed farming, introduced in 1989, where the seaweed seeds exported from the Philippines. In 1990, seaweed farming spread to all villages in Pemba and Tanzania mainland as well. Two species commonly farmed in Zanzibar. You know, there are a majority of seaweed species, but in Zanzibar, we are mainly farming two major species, which is Capophycus alvaris and Eucoma denticulatum, which is commercially recognized as cottony. In Swahili, which we call mwani mwembamba, and the spinosam in Swahili we call mwani nene. Cottonelle in Swahili we call mwani nene, and the spinosam in Swahili we call mwani membamba. So the map show the distribution of seaweed farming in various villages, you know. So there are about 8 villages, Zanzibar, where it's currently, engaged, whereby the seaweed farmers currently engaged in seaweed farming. But in Pemba Island, seaweed farming has been concentrated island. Pemba producing more seaweed than Unguja, definitely because, the Pemba Island is in a unique island where it is in a protected island where the strong current tides not affected much in seaweed. So the production is quite higher in compared to Unguja Island, where majority of shore, coastal line of the shore is open, is closed, is open. So there is a very strong current that affects the significantly production of seaweed farming. So seaweed farming in Zanzibar play a very significant role in blue economy. You know, the current establishment of Ministry of Blue Economy in Zanzibar in 2020. So there are 5 specific priorities for the government. So one among those priorities, there is aquaculture, fisheries, maritime transport, there is marine conservation, there is oil and gas development, and coastal tourism. But when you talk about the one among the priority areas is in aquaculture, and which is specifically in seaweed farming. So Zanzibar Archipelago is the first in Africa in production and export, a very huge export in seaweed globally, but is among the 5 top in production and export in seaweed globally. And our market is mainly focused on Asian countries, which is China, Philippines, and Japan. 26,000 of the people, which is almost 80% of the women. So look in picture here, so you can see the majority of seaweed farmers in Zanzibar are the women, that are counting 80% of the women along the coastal regions of Zanzibar. So in order to participate and engage in seaweed farming, there are some materials should be available over there in order to participate. You should have some page. You may have a look here. It should have also tie and ropes. There is a 3 main ropes that are mainly used in seaweed farming in Zanzibar. There is also a knife and hammer, some fire, light fire here, and there is a boya also are used in majority of seaweed farmers. So these are the majorities of the materials that are needed for engaging in seaweed farming. Although there are other materials like bamboo also can be used in many of the countries like Philippines, but in Zanzibar, majorities of the materials that are mainly using are this kind of ropes, which are in difference. There is a 1 millimeter rope, which is called tie rope. There is also 4 millimeter ropes. This one which is for tying the seaweeds, and there is a currently emphasizing seaweed farmers to use the very thick ropes, which is about 8 millimeter or 10 millimeter, in order to minimize cutting down of the farming techniques that are commonly using in seaweed farming in Zanzibar for seaweed farming in Zanzibar. So the first one is the bottom single tai farming. You may have a look here. There is a single tai farming. This is a local method for farming where many years the city farmers have been using in this way. There is another way here. There is a improved double mud loop tai farming. Here there is a single tai, and here there is a double tai methods of farming where we believe this method. I mean, there is a double production compared to this or bottom single tai farming. Then this method also reduce the clearing of the mangrove stakes and then forest stakes. You may have a look here. There is a single, there is a page here, and then there is first page and then second page. So here there is an improved method of farming techniques where we're using the crops here, which is about 8 to 10 millimeters. So there is a decreasing the numbers of the pages in here compared to this method. There is another method of farming which is called the floating method. So we are normally using bamboo and other floating pages. So we are attaching the ropes here and then seeds, and then we are floating by using down there or down on the surface of the ocean. But also there is another method which is commonly using in Zanzibar, which is the tubular net seaweed farming method. So we are using we are putting the seed within the PVC pipe and then drop some kind of seeds there, and then we tying there, and then we remove the pipes, and then finally we should have some anchor. I mean, tying together, and then floaters at the surface of the ocean, and then finally the seaweed growing very well, and then there is a declining of dropping of some seed compared to these other methods of farming. Let's have a look the seaweed production in Zanzibar. Here there is a graph showing our production from 2014 to 2023. So the production and the exportation of the seaweed in Zanzibar has not static. There is a dynamic. There is a various numbers that affect the production and exportation. Among them is the price, not only the price but also the environmental condition like global climatic changes, temperature, and salinity that significantly affect the production of seaweed in Zanzibar, so that there is a decline of the production. You may have a look here. Our maximum peak of the production, it was 15 and 3, where the production was nearly similar, which is we export the outside of the countries. So in seaweed production in Zanzibar, only 2%, about 2%, we are using in our local region in Zanzibar, but more than 89% we are export outside of the country. Only 2% in our home country that we are using in production of various local products like soaps, lotions, oils, and massage oils and other products. And currently the seaweed are using in as a inclusion of our meals, making soap, making other useful products. So there is currently the government of Zanzibar, revolutionary government of Zanzibar, through the establishment of Ministry of Economy and Fisheries, have been planned in different strategic priorities to ensure we are increasing the production. Among them is to improve the productivity of seaweed, such as makes more meaningful contribution to household income, diversify and develop available end market for Zanzibar produced seaweed and seaweed product to absorb increased productivity and stabilize or increase prices. Still the price of seaweed in Zanzibar is not huge. 1 kg for the spinosam, it is 800, but the cottony, which is higher in price, which is around 1,800. Also, the government currently address sector-wide quality issues that undermine the ability for Zanzibar produced seaweed conduct interventions such as minor and promote that protect the build upon the unique role of women. Also improve farmers who have abandoned seaweed production and roles among the blue economy opportunity, in particular sea cucumber farming. So another currently, recent development in seaweed farming in Zanzibar, there is a establishment of Zanzibar Seaweed Company, which is called ZASCO. This factory, which is located at Pemba, the main function of this factory is to increase the value addition for seaweed farming, for extraction of carrageenan, which is very, very valuable in production and useful in producing in many products. So the industry, expect to need about 30 tons annually. So, and if you have a look very clearly, the current production is about 16,653, but we plan to increase the production due to the establishment of this factory. We need about 30,000 of tons annually. So this will be achieved in different other strategic plan that I will explain later. Also, there is a construction. The government plan to construct 2 the strategies that government currently taken, to encourage the seaweed farmers is to provide the seaweed farmers various, tools for farming, like boat or, harvesting and then go the deeper water seaweed farming. There is also, production of the ropes to the seaweed farmers, and then the government also support the technical support by providing the training on best management practice of seaweed farming using the double mud loop farming, which is called in Swahili kamati ya chini. So we believe these strategies and the recent intervention will help to improve the production of seaweed farming in Zanzibar. So, as a ZAFIRI Research Institute, we are emphasized more research in doing more research in seaweed farming. ZAFIRI currently, established the pilot study on development of new strain, because we are farming the seaweed by using 2 major species, which is spinosam and cottony. But we believe these species currently faces with a major challenge in global climatic changes, particularly temperature and salinity. So as ZAFIRI Research Institute, we plan to develop the pilot study on development new strain in the lab in order to develop more strain that will be resilient and so value addition is the one among the strategic plan for the government. Currently we are emphasizing local government to, add value in seaweed farming because the price is very low, but we believe when we develop, value addition in production of various products in seaweed, this will increase the prices and then will generate the income to the local community. So in adding value in seaweed, currently we've been using seaweed for grinding and producing more powder for production in various useful product by using the seaweed. It's like oils, lotion, salad, juice, tea. Those are among the seaweed products which are currently producing by using seaweed in local market and local seaweed farmers in Zanzibar. So let's continue to discuss about the challenges that are facing in seaweed. There is a price. I think I explained very clear the price currently in seaweed farming in Zanzibar in those two species. But there is a climatic changes, particularly salinity and increasing salinity and the temperature. And because majority of seaweed farmers, engage in seaweed farming in shallow water areas and shallow areas. So during the low tides, so when the water, away from the shore, some of them, the seaweed, totally exposed in the ocean surface. Some of them, the seaweed remain under the ankle, under the knee, and under the ankle. So they are facing a lot of seaweed drying and the production decline always. And then there is the epiphyte, and then epiphyte inversion in seaweed farmers, some of the season. And then there is also disease which is called ice. It's like during in the front of the seaweed, there is like seaweed is rotten. So during the high current, it is easier to wash it away because the ice there is a fine signal of front, and to be rotten. So some of the ocean current affect much in many areas of seaweed farming. There is a very big challenge of gender unlocking and youth engagement. Majority of seaweed farmers, they are aged from 46 years to about 60. So we are lacking the numbers of youth engaged in seaweed farming. This decline significantly production in seaweed farming because majority of seaweed farmers are women. They are not able to go far because they are not understanding how to swim. So this affect the production to be high themselves. Also, there is a coastal development. This is one among the challenge. Zanzibar is the one among the beautiful island where there is near the shore there is a high concentrated of the hotels. So some of the hotel, there is a conflict of interest between the city farmers along the shore and the hoteliers where they would like to use the beach and the ocean for in different ways. So sometimes we are facing the challenge. So the current development partners, these are one among the recent development. Currently we have various stakeholders that support the seaweed farming in Zanzibar. There is a FAO, the Nature Conservance, IFAD, Good Neighbors, Maisha Bora Foundation, Milele Foundation, Zanzibar Seaweed Cluster Initiative, and then there is also academic institution, Mambao Coastal Community, IUCN, USAID, Heshim Bahari. So these are among the major stakeholders that support the seaweed farming in Zanzibar, and then they support in different ways. They are support in technical support, they support in training, they support in research, and they support even, materials for seaweed farming in Zanzibar. So these are the recent development in seaweed farming in Zanzibar. So you may have a look. We are farming, but we are also get support in different donors outside and inside of the country. So I would like to say thank you so much for this presentation. Thank you so much. And thank you for paying me attention.
Yeah, thank you so much, Zahor, for your presentation. I think we have a first question online from Anup Mahajan. He says, this plan looks very impressive. Is there any research you are taking up to quantify the secondary impacts of this farming? For instance, carbon sequestration, changing coastal biogeochemistry, ecology, things like this.
Thank you so much. This is a very, very impressive question to me as a research institute. To be honest, there is a few research that is currently being done in case of quantify the carbon sequestration and assess the geochemical processing in seaweed farming development. So so far I can say I think that there is a few research on that particular area, but I think that research is very, very useful because seaweed is the one among the plant that support the carbon sequestration, absorb a lot of amount of carbon. So it it's like as a carbon reservoir. So I think there is a need, to conduct more research in to assess the quantification of seaweed in carbon sequestration, and then also to assess the seaweed function in ecological, especially in geochemical process. But I can say we call all the researchers, all the partners, donors, to support the various research like you have been mentioned. So will be appreciate if we'll make some collaboration in doing the very, very, very useful research like you mentioned. Thank you so much.
And thank you for this answer. Hopefully somebody picks up your call on collaboration. That seems very interesting. And there's a second part to his question. He said, is there also scope to do this farming over areas further away from the coast to avoid the shared areas issue you mentioned for the tourism, for instance? Or is this not possible due to logistic reasons, or I don't know?
Please, can you come first? Can you pardon, please? I didn't hear you well because there is a network problem.
Okay, yeah, I can repeat. So he also asks if there is any scope to do the seaweed farming over areas further away in the sea to avoid the shared areas issue which you mentioned with the tourism development, or is this not possible due to logistical reasons?
Thank you so much. As a government, I think government, try to, to develop a lot of strategies, to ensure the conflict of interest between the seaweed farmers and the hoteliers and the hotel owners, reduced by providing the training. And then the currently government plan already started the marine spatial planning. I think this is the one among the very, very important thing in order to remove and then to decline, to overcome those challenges for the ocean space. So one among the strategies that is currently government taken is to establish the local marine spatial planning. They are starting for making the local marine spatial planning, and then they also plan for regional for the whole the ocean for planning in order to make the seaweed farmers the specific areas for farming, and then the specific areas for hotel development. So these are among the intervention taken by the government, and also training to reduce some of these conflict. I think this is not a big deal for the government. Really, they are really keen what we are saying as a government. So it's not a big deal, but I try to address as a challenge which are currently facing.
Yeah, thank you. I don't see further questions, but I would like to ask one. You mentioned that there is a unique role of women in this seaweed farming. Could you expand a little bit on that? What is so unique about the role of women? And also you mentioned that they mostly can't swim. So is there any plan to install like swimming lessons or something? If that's really a major limitation for them to go further abroad and increase their productivity.
Yeah, majority of seaweed farmers, as I mentioned, are the women, which is about 80% of women. So seaweed farming, I mean, pay a lot in seaweed in women in Zanzibar because they support in case of I mean tuition fee for their school kids. They also help them, I mean, to not rely or depend on women in their home, and then also they help, I mean, to increase their sound in the local community. So in doing so, the government has been working very close to this community in supporting in a lot of training. As I'm speaking now, we are supporting the training in this region currently about 100 seaweed farmers in Pemba regions. So this training supported by these donors like the farming in Zanzibar. They support boats, I mean, to go far away. Also, they are supporting the training like swimming. And then because we are encourage the seaweed farmers to go deeper areas where the climate change like temperature and salinity a little bit, I mean, not significantly affected seaweed farming in Zanzibar. So there are specific strategies that the government, I mean, put into support, I mean, to encourage the seaweed farmers, especially women in Zanzibar, and their role and their position is very clear to our to the government, to our nation, because seaweed, I mean, is a second in production and increase in income apart from the tourism in Zanzibar. So their position is very clear, and then the government support, and then they encourage them, and then support in different ways, even the materials, and then the training like to add value and to increase the income and the production. Yeah.
Okay.
Am I clear to you?
Yeah. So it seems like it's a very important role the seaweed farming is playing for the for women of Zanzibar as well.
Yeah.
I don't see any other questions immediately. If there's any other questions, please write them in the chat or just raise your hands. I was just, if I may, just a last quick question, Zahor, for you. How do you anticipate or adapt? So you mentioned that you're looking into developing other strains. Have you also tested like different species for seaweed farming, or do you have to stick with these two because of some reason?
Thank you, Dr. Padam, because there is a network. I think I don't hear what you've been saying, but I hear about the development of new strain as ZAFIRI Institute. So can you make more clear about it? Network, I am facing the challenge of network because I am in remote areas currently.
Yeah, it's okay. Yeah, I was just wondering, you mentioned that to adapt to climate change and to different conditions, you are working on developing new strains for the seaweed farming, and that you previously only worked with two major species. Is there a reason why you only work with these two species, and are there other measures you take to adapt to climate change?
Yeah, clear. I think it's a clear question. We believe in Zanzibar there are more than 8 seaweed species, but the majority are farming spinosum and cotonou, which is a major species. So currently we are planning to doing more research in other seaweed species in Zanzibar. There is a Glaciaria species. There is a ulva species of macroalgae seaweed. So those are another seaweed species that that is well growing in Zanzibar. But majorities of local communities for a long time years have been trying to cultivate by using these two species. On top of that, we are planning to to develop new strain. Those, I think the new strain is not a new strain where we export or we export outside of the country. No, it's those species where I mentioned. We'll try to make the pilot study for these species. To also to ensure if there is a possibility of enhancing and improving more seed production in other species. But still, the species where local community, normally farming will continue. But we plan also to do more research in the lab to ensure to provide these species where will be help to resistance and then resilience in climatic change. But we will not focus on other new species. The species we are planning are the species are only also found in Zanzibar, which is not yet established or not yet farming in Zanzibar. We believe that probably these species can acclimatize, can adapt the climatic changes. So that's why we encourage to do more research. To make some pilot study in develop new strain of these species in growing and to develop in the laboratory in order to do more research on that.
Do you also, like, I think that tropical storms will also increase in intensity and in frequency. Have you any adaptation plans towards this major challenge?
Yeah, I think we don't have a major challenge on that because we tried our best as a researchers, as a researcher in collaboration with a lot of donors. Because majorities of seed farmers in Zanzibar, some of them they don't know the way how to select the best site for farming. So we tried our best to collaborate with the local communities. To listen them very clearly, to get their indigenous knowledge, and then together with our experience and our skills, to select the best site for farming in order to minimize, to reduce the intensity and then major challenges facing with the environmental challenge. That we believe that will increase the production and then efficiency for seaweed farming.
Okay, thank you very much for this discussion. If there's no more questions for Zahor, I would like to thank him again, unless there's a last minute question, but I don't see anything. Yeah, okay, so thank you again, Zahor, and then we'll move over to our second speaker. Maybe you can unshare your screen, Zahor, then Apurva can start sharing. So our second speaker is Apurva Joshi. He is a doctor. He's working currently as a research scientist at the Indian National Center for Ocean Information Services, which is established in Hyderabad in India, and that's where he works since 2022. He, after a Master of Technology, which he obtained in 2018 at the Department of Ocean Engineering and Naval Architecture at IIT Kharagpur in India, he went on to do a PhD on seasonal variabilities of carbonate parameters in the Bay of Bengal, which was supervised by Professor Hari V. Warrior. And then he published since or during his PhD more than 10 papers, mainly focusing on the Bay of Bengal and the North Indian Ocean. And in his work, he's using regional coupled ocean biogeochemical models. And his favorite tools are ROMS for physical modeling and phenol-pisces for biogeochemical modeling. He also uses advanced machine learning techniques to predict carbonate states in the Northern Indian Ocean. And that's what he's going to talk about, I think, today, but he can better explain that to me. The floor is yours.
Thank you very much. I'll just share my screen. I think the screen is visible to all and I'm audible also. Okay.
Yes, all is well. It's not in presentation mode.
Yeah.
Yeah, now all fine.
Hi all, I'm Apurva P. Joshi. I will be presenting my paper which is recently published in Scientific Data. The topic is Sea Surface PCO2 Maps for the Bay of Bengal based on advanced machine learning algorithms. The outline of the presentation is such that first I'll talk about the Bay of Bengal and what are the important properties and its characteristics, then rationale of this work, that why this work is required. Then we'll talk about the different data and methodology, development of the high resolution surface PCO2 maps, its technical evaluations. Also, we compared our model with the existing ML-based PCO2 products, and then we will summarize and conclude the presentation. The study region for this study is chosen to be the Bay of Bengal, which is a semi-enclosed basin. It has land on 3 sides and it's open in the south. This unique basin has also experiences seasonal reversal of monsoon winds and receives huge freshwater discharge from rivers such as Ganges, Brahmaputra, Mahanadi. The EICC, or the East India Coastal Current, which is western boundary current for the Bay of Bengal, reverses seasonally in response to the seasonal reversing monsoon winds. The high influx of freshwater in the Bay of Bengal forms the freshwater plume. The huge freshwater influx from the Indian summer monsoon creates a strong salinity stratification in the Bay of Bengal, which actually inhibits vertical mixing. And it also limits the availability of nutrient at the surfaces. So, Bay of Bengal is known for low productivity and it's also an oligotrophic ecosystem. Kumar et al. In 1996 suggested that Bay of Bengal is a sink of atmospheric carbon dioxide. But Sharma in 2015 and 2021 found that it's a mild source of atmospheric carbon dioxide due to the atmospheric deposition of the dust deposition. The general perception that Bay of Bengal acts as a seasonal sink of atmospheric carbon dioxide, it generally comes from the amount of fresh water this particular region receives. So the fresh water, it's also expected that it will have less amount of carbon dioxide and may act as a sink. But Sharma et al. 2021 reported that the peninsular rivers bring acidic and high PCO2 waters to the coastal regions, whereas the glacial rivers such as Ganges and Brahmaputra bring relatively basic and low PCO2 waters to the Bay of Bengal. Hence, the source of river water determines the direction of the fluxes of carbon dioxide at the air-sea interface. So, but lack of sufficient observations has always been an hurdle. It's for understanding the spatial and temporal variabilities of surface PCO2 in the Bay of Bengal. These limited number of observation into the existing ML products from Bay of Bengal often have very high predictive errors. And the linear relationships such as surface salinity and potential alkalinity, and this often fails in the Bay of Bengal due to the variation in the salinity, which is much more than generally found in other ocean parts. In this study, we develop a high resolution climatological PCO2 map using a significant number of open and coastal ocean observations. The open ocean observations are generally very easily available and it's freely available for public. The coastal oceans, due to the EEZ regions of the Indian Peninsula region, these are not generally available for the public. So we also collected those data from the various cruise lines from the Indian government, and we created this particular high resolution PCO2 product. And also it's associated how it is regulating the PCO2 variability in the Bay of Bengal, and that will be able to see on a climatological scale. This spatial distribution, this particular figure shows the spatial distribution of the data. So as I said, the publicly available PCO2 sources generally like SOCAT has only 4 to 5 cruise lines, and mainly it is the density of these cruise lines are into the center of the Bay of Bengal. So in this study, we also collected some of the different cruises, data from different cruises which are near to the coastal region, so that the spatial spread of the observation data in the whole Bay of Bengal region is now better. It's not the best, but it's still better than what we already had. And also, obviously, Rama is there, which Rama buoy is presented at 1590 in Bay of Bengal. It is giving us the PCO2 variabilities, and which is the PCO2 data is there, and that is also publicly quite nicely available. Before starting indulging into the ML product using the machine learning models and all these things, we first see how much data is available. So Rama is giving us a temporal data from 2013 to 2018. Obviously, it's not continuous, but it has a quite nice temporal resolution. So we see that almost in all the months, we have round about the similar number of data sets are available from the Rama buoy itself. Whereas you compare that with SOCAT data, due to the sparse, only I said 5 cruise lines are available in the Bay of Bengal. So maximum months like January, February, so the monthly seasonality is not very well captured when it comes to the publicly available data sets. So in the study, we also took data sets from Sridevi and Sharma, which are our NIO associates from the NIO Oceans, and they have given us the data sets which they have used for their studies, and which has obviously increased the number of available observations, especially the monthly distribution of these observations. Moving ahead, the methodology which adopted in this study is, as I said, we collected the data from various sources like SOCAT, Rama, different observations, and we did a bit of data analysis where to understand what relationship is standing, how the quality of that particular data is, etc. A major so in the before taking into the machine learning algorithms into account, we assume here that surface PCO2 is a function of sea surface temperature, that is SST, sea surface salinity, SSS, mixed layer depth, MLD, and atmospheric carbon dioxide mole fraction, that is XCO2, and chlorophyll. So each of these variables are kind of a proxy to the processes like the biological pump processes, which is chlorophyll is a proxy for that. Mixed layer depth, which is the mixing as well as maybe upwelling and all these things are getting proxied for that. The SST represent the thermal process, how it affects the PCO2. So accordingly, this independent and dependent variables have been chosen. Further, we choose here in this study, we have used 4 algorithms. One is XGBoost, that is the extreme gradient boosting algorithm, random forest algorithm, artificial network, and along with that, we also use multiple linear regression models. We first tune after the train test split, we first tune the hyperparameters of these XGBoost and random forest and neural networks, and then identify which is the best performing model, and so that it can be used to create the final high resolution maps. This is a Taylor diagram which shows us that XGB or XGBoost model is actually performing better than the artificial neural network and the MLR, that is the linear regression model, and the random forest model. So after the clear indication of better performance of this XGBoost model, we use this XGBoost model to create the maps of the Bay of Bengal PCO2. But for creating these maps, we will require data sets which we have taken from reanalysis as well as satellite data, so that we can create that map and it will have that spatial as well as temporal resolutions. So for that, SST and MLD we have taken from GLORIS 12v1. Salinity and chlorophyll are taken from ESSCCI and OCCCI. And XCO2 is taken from Copernicus atmospheric inversion monitoring, services. The datas have monthly resolutions. Wherever the monthly resolution wasn't available, we created into a monthly resolution, and the durations are all from 1993. So since it is cutoff time is 1993, and if you see that salinity OCCCI was only available from 2010 to 2020. 2022. So we chose this period of 2010 and 2019 to create the maps and then average it to showing the this climatology of the most earlier states. Moving on, this is the high resolution monthly map surface PCO2, which has been created using the product, whatever product reanalysis and satellite product and the XGBoost algorithm. We find that the northern Bay of Bengal, approximately like 15° north, is seen to have lower sea surface PO2 than the southern Bay of Bengal. The EICC, the East India Coastal Current, which actually moves towards the equator, is known to have a dominant control over the surface of the PCO2, especially in the western coast of Bay of Bengal. What it does, it basically the fresh water which has been accumulated in the northern Bay of Bengal from the precipitation and then the high rivers and then spread towards the southern region by this EICC or the East India Coastal Current. This reduces the sea surface salinity, which actually reduces the sea surface PCO2. The northward movement of the EICC. So if you see the Eastern Indian coast in coastal in the months of October and November, it brings in the low saline and it brings in the high saline and also high PCO2 waters into the coast. The Incois REML, which we have named this particular PCO2 maps product, well reproduces this coastal pattern for the PCO2 levels, with the lowest during the November and the highest PCO2 levels during May. A few technical validations are needed so that we know how good our model is performing. So what we did is we created a climatology from the Rama data, and whatever the product which we have made, we took that particular 15 north and 90 east, that point we have particularly taken, and we have seen how well it is performing. We found a correlation of 0.93 and an RMSE of 7.4 microatmospheres. Apart from that, we also use that 1 degree SOCAT gridded product which are available. We create a climatology referencing to year 2015, and then we compare our Incois REML with that product. We see what the seasonal, the correlations is very high, and there are some biases, especially in the eastern region and moving towards the north. But as we move towards the west and south, these biases are getting lower. The difference in the correlation and bias actually shows how much less temporal variability these cruise lines are having. So this also highlights that this kind of product is how it is important if someone wants to use this thing to validate their own models or to understand how the PCO2 distribution, both spatially and seasonally, this product will be very useful. Going further, we also used other PCO2 products, which are global products, and we used only the Bay of Bengal region to compare how these products are performing with our Incois REML. And doing a Wilmot skill score analysis, and which helps us to rank the rank the models. We find that Incois REML is doing better, which is next to just CMEMS. That is the Copernicus product, which is recently been 0.25 degree resolution and published by Chow. So while seeing that how CMEMS is doing closer to Incois REML, still Incois REML is able to perform slightly better than CMEMS. We compare the two products so to understand later that how this high resolution product is helping us to understand or to cover better coastal regions, and what are the differences with the 0.25 CMMS product. So Incois REML and CMMS perform well in capturing the spatial variations of low PCO2 primarily driven by low saline waters in the Bay of Bengal. However, This spatial variation were not well captured by CMMS compared to inquest REML in the spring monsoon season. That is, low salinity, low PCO2 is seen in the northern region in the March, April, May, and this is not very well captured in the CMEMS. In addition, the PCO2 levels in the low saline plume region were underestimated by CMS compared to inquest REML. That is because we got the high resolution. We can also see how the coastal regions are well covered in the high resolution inquest REML, which are not that well covered in the CMEMS model. So it is evident that seasonality of surface PCO2 is well captured by inquest REML. Therefore, this high resolution data is an improved version of the climatological mean state of sea surface PCO in the Bay of Bengal region. To summarize, we developed this high resolution sea surface PCO2, and we can have also seen the associated sea surface PCO2 flux data, which would immensely aid in validating not only high resolution biophysical models, but also outputs from some coastal resolutions like CMIP6 models, especially in the Bay of Bengal, where there are very less data available. Inquest REML outperforms the existing ML-based PCO2 products. This is due to two primary reasons are the inclusion of significant number of open and coastal ocean observations from different sources, which captures the coastal PCO2 dynamics better, and the high spatial resolution of the inquest REML. We understand that the product can still be improved, and we will keep on updating the product as number of observation increases. So this data product is expected to help researchers to distinguish between the sourcing behavior of the Bay of Bengal, which essentially improves the Indian Ocean carbon budget in this changing environment. Before ending, we acknowledge inquest REML data product has been developed as a part of development of climate change advisory services of the inquest under the Deep Ocean Mission Program of the Ministry of Earth Sciences. The Surface Ocean CO2 Atlas, that is the SOCAT, is an international effort endorsed by the International Ocean Carbon Coordination Projects, IOCCP, and the Surface Ocean Lower Atmosphere Studies, SOLAS, and the Integration Marine Biosphere Research, IMBR. Program is delivering to uniformly quality control the surface CO2 basis. There are many researchers and funding agencies responsible for collecting data and quality control, which we sincerely thank. And we sincerely show gratitude towards the scientists and the funding organizations and SOCAT data collections and quality control process organizers. The field program for making the ship-based observation, which is presented in the SAS data, was funded by several Indian funding agencies, Ministry of Earth Science, Ministry of Science and Technology, Department of Space of the Government of India. We also acknowledge OCCCI and ESSCCI data for producing the merged satellite datasets for chlorophyll as well as the sea surface salinity. And also I acknowledge inquest for giving me the opportunity to work on this kind of project and to produce this kind of datasets. So these are the publication details, and thank you for your attention.
Thank you, Apurva, for the wonderful talk. And I see no questions till now, so I have a question for you. So
Yeah.
is the product which you generated, the surface PCO2, so
Yes.
is that available in the open domain?
Yes, it is available. If you go to this paper, it is available in the open domain. It is also available in the inquest website itself.
Okay, okay. That's great. Okay. So yeah. Okay. Yeah. And what's the resolution in case I missed that data?
1 by 12.
1 by. Oh, that's
1
a
by
very
12
high
couple ticket.
resolution. Okay. Yeah. Great. I would love to use this data and yeah.
Okay.
Okay.
Thank you so much.
Thank you. Yeah. Liselotte has a question. Yes, Liselotte.
Yeah, hi. Thank you for the talk, Apurva. I'm not very familiar with the PCO2 fluxes, but I was just wondering if with your machine learning algorithm, you were planning to do also future predictions or looking at how things will evolve with changing conditions, if that is something you are interested in.
Yes, it is in our plan to look into the future projections. But for that, we need to be sure how our model is working in the historical period itself. And we are definitely right now looking into those things, and we have in plan. Let's hope so.
But would you need to adjust your model for this, or do you need data, specific data
We
that
need
is
data.
missing? Or?
We were thinking of maybe taking data from CMIP. Maybe it needs some adjustments or some bias corrections, like the dependable, the independent data, like suppose SST and salinity and chlorophyll and all these things has to be taken from some other sources for the mainly for the future period. So first we have to take all the data and we have to apply this same model on those historical data from CMIP and see how it is performing. Can it reflect the mean state properly or not? If it can, then it definitely we will be using it for at least for short-term future projections.
Okay. So thank you, Purva. I see no more questions in the chat. So thank you. And if anyone has questions, they can connect with you offline also. Yes. So Liz, I'll pass on to Liz for concluding the session.
Yeah, I think this is the end of our seminar. Thank you all for the interesting questions and for the discussion. Thanks, first of all, to the two speakers for being available today, which is not always easy, and for delivering the talks with a lot of conviction. And I hope we have presented you with the two organizations that were organizing the seminar today, and that some of you may be feeling that they can gain something from engaging with these networks. And if you want to do that, please get in touch with us. And also I want to remind you that the recording of the seminar will be available on both the websites, the YouTube channels from SOLAS and from IIOE too. Thank you all for listening to us, and I hope you've learned something interesting from these seminars, and hope to see you next time. Thank you, Aditi and Mansi, also for co-organizing, and thank you, SOLAS, for providing us the platform. Bye-bye.
Thank you, Liz. Thank you, guys.
Bye.
Thank you so much. Bye-bye.